for another professional development seminar. Um, I hope you're all healthy. Today's presentation is about Port of Alaska, modernization program and construction of the new petroleum and cement terminal. Our presenter is Mr. Jim Jaeger. Mr. Jaeger is Port of Alaska's External Affairs Director. He earned a Bachelor of Science at the University of Wisconsin-Madison, a Master of Art at the University of Missouri. Thank you so much, Mr. Jaeger, for joining us today, and we are excited for your talk.
Well, hello. So I'm coming to you live from Port of Alaska, and I guess we should just jump right in. It's a little odd doing this without hearing feedback from anybody, but I guess if you have questions, you can type them in and we'll go over the questions at the end. So Port of Alaska is a municipality of Anchorage owned and operated facility. It serves Anchorage, the state, and the whole nation. The port opened up in 1961. When it opened up, the whole point of it was to support regional economic development here in Anchorage. Specifically, it was so that we could get some fresh groceries into the grocery stores. The Anchorage Assembly renamed Port of Anchorage in October of 2017 to reflect its regional, statewide, and national significance. Let me see if I can get this thing rolling. So that is the port right there. So we ought to start a little by talking a little bit about Alaska. Alaska is a consumer state. We're in an unusual situation in that for the United States, in that we have very little agriculture or manufacturing in the state. And that means that we have to import the vast majority of the food and goods that we consume. The state is a virtual island. Even though we're connected, about 90% of the goods that we consume are imported by either a ship or a barge. Air and trucks both account for a little less than 5% of our inbound cargo. Most of the food and consumer goods that we ship, more than 2 million TEUs, that's a 20-foot equivalent unit. Think 2 TEUs to a typical truck that you see on the road. We imported more than 2 million TEUs in 2019. Most of that was carried by either Matson or tote and delivered to Anchorage. Alaska, mostly the Port of Anchorage, or the Port of Alaska in Anchorage, accounts for 20% of the freight that ships out of Port of Tacoma every year. And that Port of Tacoma freight comes either to Anchorage and in some cases goes to Kodiak and Dutch Harbor, not because those markets are big enough to support the container traffic by themselves, but because Matson is sailing right past them on their way to and from Anchorage so that they can conveniently serve them. About 5% of our freight comes up by air, or a little less than 5%, and a little less than 5% drives up the highway. It's a 2,300-mile road, mostly 2-lane. Takes drivers anywhere from 45 to 70 hours to make the drive, depending on the weather conditions. That same marine trip, so the ship voyage from Tacoma to Anchorage, takes just under 3 days. So a truck is a little bit faster, but it's considerably more expensive. If you look at all the freight that comes in, Port of Alaska is the state's primary inbound cargo handling facility. We handled 4.3 million tons of fuel and cargo in 2019. Goods that come across our dock are eventually consumed by about 90% of Alaska's population. Port of Alaska handles something like 80% of all the vans and containers that are shipped into Southcentral Alaska ports. We're about 75% of all the non-petroleum marine cargo shipped into the state of Alaska. That's exclusive of Southeast, which gets most of their cargo shipped by barge directly up from Tacoma. We account for about half of the freight that comes into the state of Alaska by all modes, and about half of the freight that crosses our dock ends up being delivered to final destinations outside of Anchorage. Altogether, we supported something a little more than $14 billion worth of commercial activity in the state last year. As I said, half of the freight that comes into the state keeps going to final destinations outside of Anchorage. Our level of business is relatively stable. Our business, if you want to predict whether Port of Alaska business is going to go up or down, look at the state's population. And our cargo loads move in almost perfect unison with the state's population. More than 80% of our cargo is inbound. So what just happened there? Let's talk about COVID-19. I've had a bunch of people asking, what's going on with Port of Alaska's freight? You know, the shelves at the stores are all empty. Port of Alaska has had no coronavirus related service delays. And we don't anticipate any fuel or freight delays because of coronavirus. We're still going to have normal issues, storms out in the Gulf of Alaska, mechanicals that could delay traffic. And I expect that our cruise ship season is going to basically not exist. We were originally expecting 14 visits this season. That's probably off. But Tote, Matson, all of our fuel shippers, the Northwest Seaport Alliance, that includes the Port of Tacoma, all say they expect to maintain normal operations throughout the COVID-19 pandemic. Everybody is implementing some special operations. For example, the ships, both Tote and Matson, are now isolating their ships so that nobody's getting on board and their crew isn't getting off so that they don't contaminate the crew members. U.S. Coast Guard, Customs and Border Protection, Center for Disease Control, they're all following their normal protocol for discovering and dealing with sick ships. But the short story is that our container traffic, our fuel and freight, inbound fuel and freight, is not being impacted by COVID-19. Now, why are the store shelves empty? It's not because of the shipping. Empty store shelves are in Railbelt, Alaska, are really the result of a spike in demand that's probably COVID-19, not probably, it is COVID-19 related. People want to have more supplies in their house in case they get stranded in their houses for a while. They are not consuming any more toilet paper than they did last week or the week before. We have just as much toilet paper and other products in the state as we usually have. The difference is it's sitting in people's pantries instead of sitting on the store shelves. The only thing we're probably consuming more of is hand sanitizer and certain cleaning supplies. And those are legitimately running low because the suppliers can't produce it fast enough, not because we can't deliver it. We have plenty of shipping capacity. Store managers are ordering new stock. The trick is, because we're so far away, it takes anywhere from 5 to 7 days after the order is placed to get the goods from Tacoma onto our store shelves. That's why the shelves are emptying out. And as soon as people resume their normal buying patterns, the shelves will stay full. You know, we're going to have the back end of this demand, this sudden surge in demand is going to happen later this summer when people start looking in their cabinets and going, why do I need 3 cases of toilet paper? And they're going to stop buying toilet paper. And all of a sudden, the shelves are going to stay more full than usual, just not because we're using more or less product, just because the buying pattern is going to change. So what does Port of Alaska have? We'll get back to our regularly scheduled program now. What does Port of Alaska have? We are the state's most versatile cargo port. We are not the biggest port in the state. The biggest port in the state by tonnage is Port of Valdez, and they are a specialty export facility for petroleum. Second biggest port in the state by tonnage is Port of Nikiski, which is also a specialty export facility for petroleum products. The third busiest port in the state is actually the Red Dog Mines facility up in the Chukchi Sea. So that's a specialty export facility. We are the state's biggest inbound cargo facility, and we are the state's most versatile cargo facility. And that's because of the types of infrastructure that we have here. We have 3 general cargo terminals. We have lift on, lift off, roll on, roll off, and break bulk capability. We can handle liquid bulk, petroleum. We can handle dry bulk, cement. We have a dry barge landing. We handle cruise ships and cruise ship passengers. So we are the only port in the state that can basically handle every type of cargo that typically travels by marine vessel. Cargo handling logistics and efficiency are typically driven by 3 things. 1 is proximity to market, 2 is the infrastructure at the port, and 3 is transportation connections. Port of Alaska is at the state's population and business hub. 40% of all Alaskans live in Anchorage. 60% live within a 2-hour drive of our dock. Port of Alaska's docks, Port of Alaska's docks leverage and are leveraged by hundreds of millions of dollars of freight-related private sector infrastructure. We have 125 acres of cargo handling infrastructure here on the port, plus quite a bit of other additional railroad-owned lands in the vicinity of the port. We have 3.4 million barrels of fuel storage on the port. We have 60,000 tons of cement storage on the port. We have dock cranes, roll-on, roll-off ramps. We have docksiders for cement handling. We have all of this infrastructure. And then the key thing we have is we have a skilled workforce. On a typical non-ship day, we have maybe 225 people working on the port. On a ship day, when Tote and Matson are offloading their vessels, that number increases to about 1,250 workers. It takes a lot of workers to distribute Alaska freight. Port of Alaska is the state's main intermodal transport hub. We connect the state's primary cargo distribution systems of air, marine, rail, pipeline, and of course, roadway. Ted Stevens International Airport and the J-Bear runways are both within sight of our dock. Linden, Alaska Marine Lines, and North Star barge terminals are both immediately adjacent to Port of Alaska. We have multiple rail connections on the port, and we're immediately adjacent to the railroad's main cargo yard. We have a valve yard and pipeline system on the port that connects our 2 fuel docks, all of our fuel storage, J-Bear, Ted Stevens International Airport, and all of the petroleum infrastructure down in Nikiski. If you want to get product from any one of those places to any of the other places, it goes through our valve yard. And of course, we're on the road system. 75% of all Alaskans live on roads that are connected to Port of Alaska. All of this connected infrastructure gives the port more and more efficient inbound cargo handling capacity than every other port in South Central Alaska combined. So what does the Port of Alaska do? This is important when we talk about the docks here in just a minute. We really have 3 roles. Our first role is commerce. That's the statewide cargo services and economic development services that we do. Our second role is national defense. National defense really doesn't generate any special revenue for the port other than the revenue we get from handling cargo that's Department of Defense related, but it's a key mission. And then our third goal is disaster resiliency and response. So on the commerce front, our main business and the business that generates virtually all of our revenue is bringing cargo into the state of Alaska for distribution around the state. The port has been cash flow positive ever since the 1964 earthquake. That means it uses no tax dollars or other public money to support its ongoing operations. The entire state benefits from our port. About 90% of the liquid fuel shipped into South Central Alaska crosses our dock, including most of the jet fuel used at J-Bear, half of the fuel used at Ted Stevens International Airport, virtually all the avgas used statewide, even down in Southeast. About 80% of the cement used in our state crosses our dock and gets distributed statewide. If you look at construction projects in 2019, the three biggest cement using projects last year were the Liberty Energy project up off of the North Slope, where they're basically building an island for oil and gas recovery. Eielson Air Force Base, F-35 infrastructure, and the Pogo Gold Mine. So three huge infrastructure projects nowhere near Anchorage that are relying on our dock. You want another example? Methanol. Delta Western has a 70,000 barrel methanol tank on the port. They import most of the methanol that comes into the state. Methanol is an anti-icing agent that the oil companies use. They put downhole in the drill rigs and in the pipelines so that oil can continue to flow during the wintertime. Our national defense role, we are one of 17 commercial strategic seaports in the world. Basically what that means is that we support the DoD mission in Alaska, the Pacific Rim, and throughout the Arctic. About 20% of the cargo that our port handles is somehow DoD related. Why is that so important? Well, it's the same thing that we support at the airport. One of the things that Anchorage has is it has a great location for air. If you look at our location, we are 9.5 hours from the majority of, from about 90% of the industrial world. So having fuel support and air support, and all that fuel is coming across our dock, lets DoD and transportation concerns like Federal Express, UPS or FedEx service the world. We're also very well located for the expanding Arctic business. Right now, Port of Alaska is the country's only existing seaport that is positioned to support Arctic transport. So, disaster resiliency. The whole Port of Alaska is key to virtually every state and federal disaster recovery plan. In most places, redundancy is the first line of defense. If you go down to, say, Port of Tacoma, if the port in Tacoma were to fail, it would be a bad day, but that port would be backed up by ports that are equally capable in Seattle, Olympia, Bremerton, Everett, Bellingham, Anacortes, Port Angeles. Then you can go up to the Vancouver area, or you can go down to the Columbia River. There are more ports. They're all on the same road and rail and pipeline systems as Tacoma. They would still get goods into Washington if Port of Tacoma failed. South Central Alaska does not have this sort of redundancy. Port of Alaska is really the only facility we have for efficiently bringing in large amounts of goods. Alaska has a 6 to 10 day supply of food in the state at any given time, so that if our port is compromised, Alaska is going to get hungry very quickly. I've heard people go, well, let's just use the road system. You could use the road system, but think of how many single points of failure there are between here and Tacoma on the Alcan. I've heard people say, well, let's just use jets. Well, let's think about jets and the efficiency of jets. Right now, Ted Stevens International Airport is the fifth busiest cargo airport on the planet. They have about 500 wide body jet landings a week that are cargo related. It would require 700 additional landings per week to replace 1 week's worth of Port of Alaska sea lift capacity. And I've heard folks say, well, there are also other ports in South Central Alaska. There are. One of the things we discovered during the '64 earthquake was that Port of Alaska up at the north end of Cook Inlet is the only tsunami-proof port in South Central Alaska. So we had a little test back in 2018, November, where we had the earthquake. It was a 7.1 earthquake. 6 minutes later, we had the 5.7 aftershock. And that aftershock was actually less than a mile from our dock. The port survived and remained open during this earthquake, but we discovered, or we confirmed, that our aging facility is at risk to earthquakes. It's supported by more than 1,400 hollow steel piles that are corroding because they're as much as half a century or more than half a century old. And we had a number of failures show up during the earthquake. We never closed, but we had problems. So our biggest issue was we had lots of weld seam failures where the welds were corroding faster than the pipe. So we had spiral seam failures. We had butt welds where you take two pieces of pipe and put them together to form a pipe. We had butt weld failures. We had vertical seams split. Obviously, all of these are loss of load-bearing capacity. We have come back in and jacketed all of those. We also had lots of fender piles break. So we have replaced fender piles. We have put steel jackets on, and we've largely repaired the port so that it's back to a fully functional mode after the 2018 earthquake. But our problem is we still have an aging port that is likely to fail due to corrosion, probably start closing docks due to loss of load-bearing capacity within the next 8 years. So the good news is we're functioning and we're going to continue to function through the COVID-19 pandemic, but we are failing. We could fail sooner than 8 years if there's another big earthquake, and that's our problem. So what we're doing is we have what we call PAMP, the Port of Alaska Modernization Program. We're moving to replace aging docks and related infrastructure to improve their operational safety and efficiency. We want to accommodate modern shipping operations because ships have gotten a lot bigger since what they were in the 60s when we first opened up. And we want to improve our resiliency for Cook Inlet's extreme conditions, both environmental conditions and earthquake. PAMP is not an expansion project. It is a dock replacement project. So I've had lots of people ask me, how is this project so big? You've probably seen estimates as much as $2 billion. We're not going to be a $2 billion project. It's more likely to be about $1 billion project. The reason it's so expensive is because our dock is actually quite large. The existing docks are as long as 10 football fields. And if you go down to the bottom of the piles, the height of our facility is about the same as the Statue of Liberty. It's a huge project. That's why it's expensive. First phase of the port modernization program is kicking into high gear this spring. Pacific Pile and Marine will start construction next month on our new petroleum and cement terminal. This initial construction, our initial construction activities that we've been doing for the last 2 years were to stabilize the shore to get ready for this project. This summer, we're going to build the trestle and the deck. And then next summer, summer of 2021, we're going to come back, install the mooring dolphins, and then all the petroleum and cement infrastructure, so that at the end of the 2021 construction season, we expect to have a fully functional petroleum and cement terminal. That petroleum and cement terminal, you can see it where the red ship is here, is south of our existing docks. Once we have that, we'll be able to move north and start a demolish and then reconstruction of our existing POL1 as a petroleum and our current petroleum and cement facility, and then our cargo terminals. We have to leave all the docks functional, or at least have the same number of functional docks throughout our construction project so that we can keep feeding Alaska throughout construction. Project's likely to take somewhere in the neighborhood of 8 years by the time we're done with it. So that's our plan, is basically in the next 2 years, we're going to build a new petroleum and cement terminal. And then we will move north, replacing the container docks. So I guess at that point, I'll throw it open to questions.
All right, I am looking online right now. It might be a little bit of a delay here. Bear with us.
I will say it was very odd doing a presentation with nobody listening, or nobody that I could see.
Oh yeah, no, we actually have around 50 people online.
I hope I didn't put them asleep.
No, it seemed like it was a really engaging. I really enjoyed your presentation here. Okay.
Sorry, I've got jets taking off behind me, so.
Okay, where are the funds coming from is a question that's being asked.
That's an excellent question. So we have a number of funding sources, and we are still developing funding sources. We started out with some money left over from the failed port expansion project. Think of the Sheffield project that happened back in the early 2000s. That was a project that was controlled by the U.S. Department of Transportation's Marine Administration and had a lot of federal and state money. We had a little over $200 million left after that project that has been spent on permitting and design work and is paying for part of the first phase, this summer's construction. We put in a new tariff increase that started on January 1st of this year that will raise revenue to repay a bond that we will use to construct the rest of the petroleum and cement terminal next summer. Actually, the bids are out on the street right now for next summer's work. So basically, the petroleum and cement terminal is fully paid for with either pre-existing state and federal funds or will be paid back with tariffs on fuel and cement that are collected from the cargo that comes across the dock. Moving forward with the container docks, we are pursuing both state and federal money. And depending on how much state and federal money we were able to get, we will also do tariff increases to repay what basically will issue bonds to pay for the construction, and then we'll use the tariff increases to generate the revenue that will repay the bonds. There is no municipality of Anchorage money going into it. It's not reasonable to expect Anchorage taxpayers to pay for a facility that's benefiting the whole state. And we are hopeful that we will be getting some Department of Defense related money to pay for the docks that DoD relies upon, and federal monies that will help offset the costs of hardening the docks so that we're a disaster response facility or a viable disaster response facility. But most of the funds, it's basically going to be paid for by Alaskans through our bonding capability and port tariffs. Does that answer the question?
Yes, I believe so. We've got another question here, which is, have seismic criteria changed since the previous port expansion project?
Yes. So to begin with, back when the original port of Anchorage was built, there were no seismic criteria. So the port that we built back in the 1960s, we could never build today. It is not a seismically stable port. And then on top of that, because of all of the development we've had in the uplands area, there's a lot more stress on the uplands than there was back in the 1960s. So that the existing dock is not even close to seismically stable. Now with seismic stability, there are really two different sets of criteria we have to think about. There's what I will call the basic building code criteria. You know, the dock is a facility just like any building that gets constructed, and it has to meet basic building code standards for life and safety. And what that basically says is we have seismic criteria that the building code has. It that will preserve life and safety of anybody who's standing on the dock. So if I'm standing on the dock when the earthquake hits, I should survive. I should be able to get off and survive. The dock may not survive, but the people on the dock will survive. The real question is, should we build a superseismic dock? That's a dock that will not only survive the normal building code standards, but will survive and remain operational after an event that's bigger than a 1964 earthquake. That superseismic is really, depending on the part of the facility you're talking about 10 to 15% more expensive than meeting just the standard code. We've done a tremendous amount of study as we've been working on the dock to understand the soils here and the seismic exposure. And yes, it's a much riskier place than we understood back in the early 2000s. And it's going to be a lot more expensive to build a seismically stable dock. For instance, the silt that we're on, depending on where you are in the port, we did a test pile program where at the south end of the port, we had to drive piles down to 135 feet into the silt till we hit point of refusal. At the north end, we had to drive them 188 feet till we hit point of refusal. That's really important because that silt in an earthquake could liquefy. If it liquefies, it starts flowing downhill. And as it's flowing, it could take the dock out with it. And now that we understand that, that's part of what's driven the cost of this dock.
Excellent. Yes, it does. All right, so we've got a few questions queued up now. Will there be any expansion given the previous Sheffield proposals?
Okay, this is not a dock expansion program. And in fact, I anticipate that we will probably end up with a little bit shorter dock than what we have right now in terms of horizontal feet of dock. It is a bigger dock in that, for instance, our piles are going to be driven a lot deeper. Right now, our longest piles are only driven 60 to 70 feet into the silt. And as I said, the new piles, depending on where you are going to be anywhere from about 133 or 135 feet to 188 feet into the silt so that they hit point of refusal. So that's bigger, even though the horizontal length of the dock will probably be shorter. We are, in fact, going to improve the capacity of the dock just because we're building it to modern shipping standards. Ships have gotten a lot bigger than they were back in the 1960s. They need bigger or deeper drafts. And we are, right now, our docks, for instance, are dredged to 35 feet. We can't dredge any deeper than that because of the short piles that we have. The new berths will be capable of 45 feet. And because of that, that means you can handle bigger ships. Bigger ships, for instance, with tankers, if you bring in a bigger tanker, you need fewer tankers. So in fact, our capacity will go up, even though the dock length hasn't gone up, just because we're using modern facilities. But it's not an expansion project.
All right. Will the state be putting any money in giving its services all of Alaska? I think that gets back to the funding question.
Well, that's a really good question. I certainly hope they will. They have put in some money into the PCT. We've gotten, well, I think probably about half of the PCT. Don't quote me on that number, but in the ballpark of half of the PCT will be paid for with state funds, either that were left over from the original project or grants that we've gotten in the last 2 years. We've also gotten a number of federal grants that are supporting the petroleum cement terminal. But that's a question the legislature is going to ask. We were originally hoping that the legislature would put a general obligation bond on the ballot that would have included money for Port of Alaska reconstruction or modernization. But with the COVID-19 pandemic, they are trying to get out of Juneau as quickly as possible, and I don't believe that's going to happen this year now.
All right, that does lead us into our next question pretty nicely. So when the modernization is complete, will there be 2 PCT terminals and 1 petroleum for 3 total?
No. our existing facilities are aging out. In fact, our second oldest dock right now, and probably the dock that is at highest seismic risk, is POL1. That stands for Petroleum, Oil, and Lubricant. POL1 is actually both it's where we handle our cement right now and what we handle petroleum with. That will be the first dock to be demolished to make room for a new cargo terminal 1. So after we finish the PCT, we will move north and demolish what we POL 1 and cargo terminal 1 right now here. Sorry, if you look at, you can see T1 and POL 1. The plan will be that those facilities will be demolished, and then we will build a new cargo terminal berth there. The biggest difference is because new ships are longer, the new cargo terminal will basically be as long as those two terminals combined. And then we're going to move it about 50 feet farther out into the ocean in order to put us into deeper water so that we can handle the deeper drafts without having to dredge more. Next, or another question, or does that answer the question?
You're actually doing a really good job of leading me into the next questions, but just to clarify on the last one. So this slide that you're currently on, is that going to be essentially the docks as we see them moving forward, all of the terminals?
Well, so where the red ship is the petroleum cement terminal. That dock is not there today, but at the end of 2021 should be there and should be fully commissioned. So once that's operational, that will let us close POL 1 down. Right now, POL 1 is the only dock we have that can handle cement. So I can't close that dock, POL 1, until I have a new cement terminal and a new fuel terminal to handle some of our fuel capacity. One of the benefits of the PCT is because it's a modern facility and because it's going to be located closer to ABI's cement facilities, that big dome that you see, and the silos off to the right side of the slide. That's where ABI stores its cement right now. Right now, we have to send all the cement through a 2,200 foot line to get it from the ship into the cement storage facilities. After the PCT opens up, that run will be more like 750 feet, and we will be using a modern docksider. That's the cement offloading operation. So we're actually expecting to cut our cement offload time in half. So right now we get about 4 cement ships a year, and each ship takes about 2 weeks to offload. After we have the new dock, we'll only be offloading, so that's 8 weeks of total cement ship time per year. After we have our new dock, we'll only have about 4 weeks of cement ship time per year. So that means we're going to have 4 more weeks of capacity that we can handle petroleum ships at that dock.
Okay, and you may have reviewed this already, and I apologize if you have, but is POL 1 then going to be reopened at some later date after it's closed down?
POL 1 will be demolished and T1 will be demolished in order to make room for a new cargo dock. And the new cargo dock will be in the same location, but 50 feet farther out into the ocean. But in terms of when we're all done, after this whole project is done, what we expect to have is a dock that is more or less, total dock length will be more or less what it is today, probably a little bit shorter. But instead of having 3 cargo terminals, we'll have 2. They'll take about the same length, but because ships are bigger, it'll be spread over 2. And our overall terminal will be about 50 feet farther out into the ocean than our current terminal, and it will be about 400 meters south of our current terminal. But the overall length will be more or less the same, as I expect will be more or less the same as our current terminal. I can't say that with certainty because we haven't designed the new cargo terminals yet. We're still working on that, but the expectation is about the same length of total dock, about 50 feet farther out into the ocean so that we're into deeper water and a little south of our current facility.
All right, excellent. And then that's the last question that I see is about dredging. And can you say anything about the deeper dredging to accommodate larger vessels?
We anticipate right now, Port of Alaska is the most dredged port in North America. We dredge something on the order of $2 million. I'm sorry, 2 million cubic yards of material out of the terminals every year. That's because of our high silt load in our water, because of all the glaciers that are feeding us. When we build the new facility, if you talk to 10 different engineers, you'll get 12 different answers about how much the new dock, as it's positioned a little farther out away from shore, will reduce the dredging. They all disagree on exactly how much less dredging we'll do, but they all agree that we will have significantly less dredging than we have today. Just because of the design changes, we should be in faster moving water that will not be have as much sediment settling out and filling into the terminals.
All right. And then we do have another question. Can you comment on any expected energy and energy efficiency improvements due to the modernization?
We'll have a number of efficiency improvements. You know, of course, all of our, well, we already have LED lights, for instance. The cranes will be a modern crane. Right now we have 3 38 gauge cranes. I anticipate we will have 4 100 gauge cranes. They're electric cranes. The current cranes draw power when they're lifting, and the new cranes will not only draw power when they're lifting, but they'll actually generate power when they're putting loads down, when they're lowering loads. We will have some sort of a, I don't know if it's going to be a battery or a flywheel that will be on the port to help level those loads, absorb that power, and then feed it back into the system. ABI system, when we shorten our line from 2,200 feet down to under 800 feet, we'll use considerably less electricity to offload the ships. Also, we'll be offloading for a shorter time. The vacuum, if you will, it's basically a giant shop vacuum they use to offload the ships, will only be running for half the time. So we have a lot of small improvements that altogether we should have a much more sustainable port in terms of energy consumption.
All right, excellent. I do not see any more questions. There was a comment that I thought was noteworthy. Today is the 56th anniversary of the 1964 earthquake, and we've learned a lot in the time since then. Thank you for covering some of that knowledge. So yeah, you know, we do have a lot of interest in seismic here, and you know, we really appreciate you taking the time to give us this presentation and answer our questions.
Well, cool. And yeah, as far as the seismic goes, you know, one thing to keep in mind, liquefaction is our big problem. You know, so liquefaction in the event of an earthquake is basically when the soils liquefy and start to act like water, if you will, or liquids. Liquids flow downhill. If you look at all of that container yard you see up there, that's about 80 vertical feet higher than the berths where the ships are. Because remember, at low tide, our berths are at least 35 feet deep. So that means it's really a pretty steep hill from the container yards into the ship berths. And the problem is if we have liquefaction, all of that uplands is going to start flowing downhill, and it will basically flow through the dock, through the wharf piles, and into the ship berths, and then the deeper water out in Cook Inlet. And the danger is that as all that stuff's flowing through the piles, it's going to basically knock the piles out, sort of like a football player getting hit by the ankles, and just sweep the legs of the dock out from underneath it. And with the new dock, because we will be driving the piles down to a point of refusal where they can tie into the firmer soils, we anticipate that that will be a lot less risk of happening. We're also stabilizing the shore. Can I answer the question or the comment?
Yes, and thank you very much. It does look like we have run out of questions.
Cool. Well, I hope I entertained everybody.
Yeah, no, I think you certainly did. And I really appreciate all of the all of the time you've taken to, like I said, answer our questions and give us this presentation. It was outstanding.
Well, thank you.
All right, thank you. You have a good day.
Bye now.